welcome back. Now, last time we spoke, I said I'm going to give a recipe for balancing a chemical reaction. Before we can do anything with a chemical reaction, if they haven't told you that according to the following balanced chemical reaction, if they haven't told you it's balanced, then you have to assume it's not. The other thing is, if you see numbers in front of the molecules or compounds, like for example 2H2SO4, then it means that it has been balanced. These indicate that it is balanced. Okay? But always check. They usually will tell you if it is balanced or not. Okay? So always check that it's balanced. Usually a giveaway is if there's a number in front of the substance or the molecule or the atom or whatever, it's probably been balanced. Right, let me get back onto this. So let's have a look. They've given us a chemical reaction, okay? Just to recap, on the left-hand side, we have reactants. On the right-hand side, we have products. That's the stuff that we are. The new stuff, okay? We can be synthesizing, which means making, or decomposing, which means deconstructing it, breaking it down, okay? And we're going to put an arrow saying this goes to that. Now, left-hand side, right-hand side, over there like that, the reactants to the products. Now, we write it down. Now, the first thing we have to do is remember we've got the conservation of atoms. So the number of atoms of each and every one has got to be the same on both sides, hasn't it? So if we've got oxygens here, there must be equal oxygens, hydrogens, sodiums. That must be equal to that. Ditto. This must be equal to that. Whether it's a 3 or a 2 or a 7, it doesn't matter. And this number must be equal to that number. Always, right? That is conservation of atoms, because the atoms you start with must all be used or changed around to the other side, correct? So, how do we balance it? Well, there's a recipe for it. And probably write it down. It's worth just taking it down. It's one I use. Okay, so we say, right, step 1, right, is balance. First of all, obviously, okay. Let me start off straightforward over here. Count how many. Okay, that's not how many. Count how many atoms of each on left-hand side and right-hand side. Okay, so that tells us if they are equal, then the reaction is what? It's balanced. Isn't it? If they're equal, if the number of atoms of everything on the left equals the number of atoms of everything on the right, it's balanced. You don't have to do anything. Okay? If they are not equal, then it is not balanced. Right? So what we do is step 1, we count the atoms on the left and the atoms on the right. And remember, NH4, 3. That means I've got 3 N's and 3 times 4 hydrogens. There's 12 of them. Remember, don't be confused by it. Means multiply each one inside the bracket. So if you've got CO2N on the inside, 3 and a 2 there, it's going to be C2O4N6, 6, 4 and 2 of those, right? Okay, so we count each and every one on the inside, on the left hand and the right hand side, okay? Just let me erase that lot. Okay, let's now assume they're not balanced. Therefore, we're now going to start the balancing process. Step 2, okay? balance metals first. Step 3, balance non-metals. Okay? Balance the non-metals. Okay? Step 4, balance hydrogen. Step 5, yep, you got it. What's left? Balance oxygen. Okay, so let's go through it again. Step 1, we count the atoms on the left and count the atoms on the right and have a look. Have we got an imbalance of atoms? Be careful where you've got polyatomic groupings inside brackets. NH3 2 or CO3 3, for example. The 3 on the outside comes into the bracket. It's the number that we've got. Because why? If they tell us, let's just recap it very quickly. Okay, what does it mean? If we've got SO4 and 2, it actually means you've got an SO4 and another SO4. There's 2 of them, which means there's 2 S's, 2 O's, and 8 8 oxygens. Okay, it would help if I had my glasses on, wouldn't it? And 8 oxygens there, right? S, 2 of those, and 8 oxygens. So don't be, just make sure you get that right, because it really is a critical part of the calc. Okay, so then we say, okay, if they are equal to each other, then it means that it's balanced. If it's not, it's unbalanced. Next step, balance the metals. So have a look. If I've got 1 mg this side and 3 mg's that side, I make 3 this side. Okay, we're going to do some. 3 this side. Okay, then I say, right, balance the nonmetals. Maybe I've got a nitrogen here and an N2 gas this side. Then it means I need 2 N's this side. So balance that. Then add up the hydrogens. Okay, remember, each time you've added a number in, it's affecting. So if there's an NO and you've put a 2 in front, it changes the O. But we'll do an example. Then we're going to say the hydrogens are balanced. The next thing is we're going to balance the oxygens, right? Okay, let us have a look at an example of this, okay? Shall we? I've got a couple here, and there's dozens and dozens in your book, okay? First of all, I'm going to say here we've got H2SO4, okay? And I'm going to call that aqueous, plus Fe, iron. H2SO4 is what? Sulfuric acid. Okay? Goes to, and this is what they tell us happens. We don't have to, it goes to Fe2SO4 3 plus hydrogen gas, H2 gas. Okay? And I'm going to say this is also aqueous over there. All right? And Fe over here, I'm going to say, let's say that was a solid. So it's a piece of iron, and it's gone to iron sulfate, and hydrogen gas has been given off. All right? They've told us this. Okay? So now, in the balancing process, okay, I want you to write next to what you just did in, I'm just going to do it in red, put in NB. Never change subscripts. Okay, what are the subscripts? The subscripts are these bottom numbers here. Okay, the 2 and the 3, that's a subscript there. Those are, one of my students actually called those the baby numbers. Okay, we leave them alone. They are already there because that is how it forms. OH2. Remember, if it is not H2Os, 1 O, 2 H's, then it is not water. So you cannot change that bottom there, because that is then not what they have given you. Okay? I quite like the baby numbers thing, but I'm not going to use that. But right, so now what did we say? We said, okay, let me just tidy up there and tidy up over there as well. All right, and put that back because that was a 3. Okay, we said, first of all, look at the metals. Here, step 1, and there is 2. Okay, so what have I got here? I have got 1 and 2. Therefore, I have to add a 2 in that side, don't I? Now I've got 2 iron and 2 ions balanced out. Okay, this looks like this, doesn't it? Fe and an Fe, and basically there's linked into these two is SO4, SO4, SO4. That's what it looks like. 2 of those and 3 of those are linked together. All right? So, right, now what do we do? Okay, well, we say, okay, we've done that. Step 2, the nonmetals. How many sulfurs have I got? I have got here, I'm going to change color to red. Step 2, 2. And this side, I have got 3 sulfurs. Right? No, I haven't got 2 that side. It's step 2. It's step 2. Sorry, I was getting myself confused. Step 2, I've got 1. So what do I have to do? I have to multiply that by a 3. Right? So I've got now that. So, okay, my sulfur. Next step, we say, okay, let us look at now hydrogens. Okay? Hydrogen on this side. Let's go to green. Okay? Hydrogen green. We say, okay, I've got 6 hydrogens here. And this side, no hydrogen there. I've got 2 hydrogens. So we need to multiply this by a 3 to get to our 6 on this side, correct? We've now balanced it. The last step is let's look at the oxygen and say this side I have got, okay, 12 oxygens. 3 times 4. You bring that number into play. Over here, I have got 12 oxygens. Reaction, or rather chemical equation, is balanced. Okay? That is what we've done. 12 oxygens. I know that looks like 120. 12 oxygen atoms and thingy that. Right? That's the steps that we followed. Right? Let us do another one. All right? Okay. Let me write it down. We've got here, okay, Mg plus O2. Solid plus O2. Gas going to MgO, okay, solid. It's a powder. What are we doing here? Magnesium and oxygen. How do we actually get magnesium that's a solid to mix with oxygen that's an air? We burn it. Anything like this is usually a combustion reaction. We are actually burning it in air, and it burns because of oxygen. Okay? Remember, needs oxygen. First of all, metals, okay, they are balanced. Okay? So step 1, I've got 1 and 1. Okay? Non-metals, there are none. Next, there's no hydrogens. So oxygens, I've got 1 there, I need 2. But now I've got to go back because I've affected the Mg. So we've got to go back and put a 2 over there. All right? So that's the process for that. Let us look at a different one now. Okay, just change it. Here's another one. Aluminium in oxygen again. Al, okay, solid, plus O2 as a gas. Goes to what? Let us say they tell us it goes to aluminum or aluminium oxide. Because when we burn something, it usually goes to an oxide, doesn't it? It becomes an oxide. All right? So I'm burning this in air, which is oxygen. So how do I find out? I've got to write aluminium oxide. I have to write it as what? As a chemical formula. Heck, where do we start? Well, We know that aluminium's symbol is Al and oxygen is an O, right? And here's where we go back to basics again. Remember, what is aluminium? +1, +2, it's in the +3. +3 family, right? All right, in the +3 group, isn't it? That's its family. Remember, they're going to act the same. Boron, aluminium, gallium, indium, tellurium are kind of going to act very similarly, aren't they? So oxygen, and here oxide has got a valency of -2. Remember, fluorine -1, well, helium and all of those, the inert gases, they don't react with anything. Noble gases is 0. Fluorine -1, oxygen -2, nitrogen -3, carbon plus our -4. So what do we say? Now we go ahead. We need a net charge of 0 because it forms aluminium oxide, not an ion. So what do? We say, right, here we go. I need to have another one of those. Well, need another oxygen. That gives me -4. Got to add another aluminium. That's another +3. So we're up at +6, -4. Add another -2. So we're now at +6 and -6. That's it. There's 2 aluminiums and 3 oxygens that go. Okay? So that's how we put together if we have to do it from words. We go back to the periodic table and we work it out using the valencies. Remember the ion table that I told you to learn? For example, if they give us iron or Mn or chromium or nickel or copper or zinc, we don't know the valency. We don't know if we know it's plus because it's a metal. We know if it's +1, +2, +3, unless they tell you +1, +2, +3, right? And yes, you do get +4s as well, but we won't go into that. Okay. So aluminium oxide is going to be, whoops, we put it in the same color, black. Right, there we go. Aluminium oxide is Al2O3, and I'm going to say it's a solid like that. Okay. Now, we have to balance, first of all, step 1, we are going to balance the metals. It's aluminium, there's 2, so we need a 2 there. Oxygen, oh, hang on, there's 2 and 3. So there's oxygen is equal to 2 and oxygen is equal to 3. Here's a tip when you get these kind of things, okay? Cross multiply, right? So what do? I multiply this one by 3 and this one by 2. Can you see I've now got oxygen equal to 6 and oxygen equal to 6? It's kind of the lowest common, isn't it, of the two. There we go, 6 and a 6. But now, okay, I've affected the aluminium. You've always got to check again, okay? Can you see the process? Back check. I have affected, there's now 4 aluminiums, so I have to go back and change that number to a 4 to make sure that that is balanced on that side, right? Let's do another one, okay? Write it in black. Here we got Mg3N2 plus H2O. Okay, this is magnesium nitride. Okay, and we are putting it, and it forms MgO plus NH3. Okay, I mean, there's ammonia coming off, right? No, we don't use this to make ammonia gas. We use nitrogen and hydrogen. It's part of the Haber process. We'll deal with it, and 2 from now we'll be dealing with the Haber process. Okay, so that's what they've told us. No, it's not balanced. We've counted. Right, first of all with metals. Mg and Mg. 1 this side and 3 that side. So put a 3 there. Right? Go to nonmetals. 2 N's are here and 1 N is there. So put a 2 there. I've got 2 N's and 2 N's there. Okay. Next I go for hydrogens. Okay. Hydrogen over here. I've got 2 H's, and here I've got 6 H's. So I must multiply that by a 3. Right? And the last one is we now check our oxygens. We've got 3 oxygens here, and we've got 3 oxygens because that 3 must be multiplied by that. So therefore it is balanced out. Okay? So the process is actually quite straightforward. That is all we do over and over again. All right? Okay? And unfortunately, it takes practice. If you follow the methods, if you come across one that you just can't do, I mean, there have been one or two that have been misprints or typos or whatever, but generally speaking, you should, using that method, be able to do all of them. Okay? It's basically quite straightforward. Okay? So you've now got the recipe for that. All right? I just want to go through some very quickly. Over here, I want to tell you, and once again, okay, acids, and the opposite of an acid is a base. Okay? This is alkaline. Don't worry too much about what the definitions are. You need to know a few basic acids. Sulfuric. That was terrible spelling. Let's try again. Need a pen, don't I? Sulf, S-U-L-P-H, U-R-I-C, sulfuric acid. Okay? Hydrochloric acid. Okay? Nitric acid. Okay? Then two more. Carbonic acid and phosphoric acid. Sulfuric acid, sulfur, H2SO4. Hydrochloric, stomach acid, HCl, also pool acid. Nitric, nitrogen must be in there, HNO3. Carbonic, H2CO3. Phosphoric, H3PO4. Where does this 3 and PO4 come from? PO4 has a valency -3. H has a valency +1. So there must be 3 of them to balance it out. Remember I told you how important it was to know those valencies of polyatomic ions. It's really going to come in now. So if you haven't got them, go back and put them in the brain, because you're going to need them. You're going to need them because it just saves you time and increases your accuracy. And let's face it, time is very important. These are acids that we need to know. Okay? There are a couple more which we deal with a bit later. Sulfurous and nitrous acid. But let's first just leave as those. Bases, okay, I'm going to do those there. Opposites, so I'm going to do it as red. Okay? Basically, these are going to be hydroxides. What are hydroxide? What is hydroxide? Hydroxyl is an OH minus. So it's anything ending in an OH. So sodium hydroxide. Calcium hydroxide. Oh, hang on. Calcium +2 -1. So I must have 2 of those, correct? Magnesium hydroxide. Barium hydroxide. All right? All of those. Aluminium hydroxide. 3, because that's a +3 -1. I must multiply it out, right? Those are bases. These are acids. Now, just so that you can see, look here. The acids have all got a hydrogen in it. And the hydroxides have all got the bases have all got hydroxides in them. Okay? Now, there's a list of reactions that you have to know. All right? I think it's in the download section. Common reactions, I think there's 5 of them. Acid plus this, acid plus that, acid, acid, acid. Because eventually, they're not going to tell you that it's an acid and a carbonate. They're going to give you an equation HCl plus CaCO3 or HCl plus Na2CO3. And you're going to have to work out what happens with those, okay? There's no getting around it. So please just go back, and it's very important, that part. Go back and just make sure that those basic ones you've got, I'm going to go over them in the next session, okay? I've got to end this one off, but I'm going to go over them in the next one again fairly quickly just to reinforce them. You can write them down if you wish. Those, and then we're going to do typical reactions, okay, where I'm going to talk about, I'll tell you now, I'm going to talk about the chemical change. We've already done precipitation, ion exchange reactions, gas forming acids and bases, and precipitation reactions. We're going to talk about those. Then we're going to move on to the last section, which is basically going to be the mole concept, okay? The stoichiometry, goodness knows how there's so many different pronunciations of that. I'll see you, and we're almost there, guys. We're almost at the end of chemistry grade 10, okay? I'm guessing that probably we'll end it all with examples, etc., probably within another 2 or 3 sessions, okay? I'm hoping to get it in under 20, together with doing some examples, etc. Thanks for watching it, and please make sure you have pen and paper next time. We're going to go through more and your periodic table. Thanks, Emil, and see you on the, what do they say, the flip side, eh? See you in the next session. Thank you.